Alright, so in problem 30, guys, we're using the same chart. The only difference is we're going to use this distance column because we're trying to see if the stinger distance, there's evidence that the stinger distance is more than the regular distance. Okay? So, let's take a look. Alright, so basically, there's your statistics from the stinger and the regular T's. So our parameter here, mu of s, is the mean distance of a ball hit from a stinger T. And then mu of r is the mean distance of a ball hit from a regular T. Alright, so the hypotheses are the null is mu of s equals mu of r, and the alternative is that the stinger is greater than mu of r. Okay, so the mean of the stinger is greater than the mu of r. The assumptions and conditions, kind of the same deal as problem 29. Okay, this is not these are random, right? Okay, we'll put down these balls are representative. I don't know that they were randomly hit, so I'm going to put down that they are representative. 6 is less than 10% of all balls hit in both cases. Okay, and then the samples are independent. And then lastly, of course, we have to assume the distributions are normally distributed. That's the best we could do with this because they did not tell us. And this is small samples, so we can't assume central limit theorem holds up here. Name the test as a two-sample t-test. Okay, we got all of our statistics right up on top. Okay, those are from the table. So the test statistics, we got to get degrees of freedom. Obtain P. T equals 241 minus 227.17 over the square root of 2.76 squared over 6 plus 2.14 squared over 6 as well. Okay, so we're going to go to the calculator. Two-sample t-test. There we go. Okay, so our mean here is 241 with standard deviation of 2.76. N is 6. The mean for the regular T is 227.17. Standard deviation is 2.14, and N is 6 again. Okay, so again, we want to see greater than, and we want to draw, and okay, so T is 9.7 with a p-value of 0. Okay, so T is 9.7, big P equals 0. Okay, now we got to get degrees of freedom. Yep. So I'm going to calculate. Degrees of freedom is 9.42. So we're going to make a decision here, right? So we're going to reject H sub O at the 0.05 level, and the conclusion is there is strong evidence that the mean distance of a ball hit off a stinger T is greater a ball hit off a regular tee. Now, what else we could do is we could look at, well, how much greater would that distance be? So I could do a little confidence interval, okay, which might help answer this a little bit. So my confidence interval would be 241 minus 227.17 plus or minus t with 9.42 degrees of freedom times the square root of 2.76 squared over 6 plus 2.14 squared over 6. Okay, so that's what we got there. So now all I'm going to do is go back into my calculator. I already got this deal in, right? I just need to look for 2 samtient. This number is 0. See it right there on the bottom? And if I look at the stats, they're already in. So it's a one-tailed test, so we're going to do a 90% confidence interval. We're going to calculate that, and it's going to come out 11.2 to 16.4. 11.2 to 16.4. Now what does that mean? We're 90% confident that a ball hit from a stinger tee will travel on average between 11.2 to 16.4 yards more than a ball hit from a regular tee, which basically supports the fact that we rejected the null hypothesis in our confidence interval. I mean, in our hypothesis test that mu of s equals mu of r. It doesn't. Obviously, 0 is not in that interval, so there is evidence that stinger tee works better.